Hello and welcome everybody to another episode of Books and Bytes.
Great to be here.
Today we're embarking on a fascinating exploration, really, into the world of prompt engineering. Our guide is Lee Boonstra's comprehensive white paper.
That's right. And prompt engineering, well, you can think of it as the art, maybe the science too, of crafting text inputs, prompts, that really unlock the power of large language models, LLMs.
Yeah, it's not just about asking a simple question, is it? It sounds like there's more strategy involved.
Exactly. It's about strategically designing your prompts. How do you get the most accurate, the most relevant, the most insightful responses possible from these models?
Okay.
And our mission today really is to give you a clear understanding of what this field is all about, why it's so important now, in the age of AI, and hopefully equip you with some actionable techniques to significantly improve how you interact with these powerful tools.
Okay, so what are the big ideas we'll be digging into from the white paper? What's the roadmap?
Well, we'll start with the basics, the fundamentals. What exactly is prompt engineering, and why is it maybe a bit more involved than it first appears?
Right.
Then we'll look at how you can directly influence the output, the text the model generates using various configuration settings. That's quite key.
Mm-hmm.
The real meat of our discussion, though, we'll be exploring a whole range of prompting techniques, from the simple zero-shot prompting all the way to more advanced methods like chain of thought, even automatically generated prompts.
Wow, okay.
And finally, we'll wrap it all up with some really practical best practices, things you can start applying, right away to get better results. We'll try to follow the white paper structure, sort of building that foundation as we go.
Sounds like a plan. Okay, let's dive in. The white paper kicks off by defining prompt engineering, designing high-quality prompts to guide LLMs to produce accurate outputs. It seems straightforward, but like you said, maybe not so simple.
It's tempting, isn't it, to just see it as asking a question. But the white paper quickly points out, yeah, effective prompting it's nuanced, it's often iterative. You try something, see what happens, refine it.
So it's not just what you ask, but very much how you ask it.
Precisely. And here's where it gets complex. The white paper emphasizes that a whole bunch of factors influence how well a prompt works.
Like what kind of factors?
Well, the specific LLM you're using, for starters. Is it Gemini, GPT, Claude? Maybe an open source one like Gemma or Llama. They all behave a bit differently.
Okay.
Then there's the data it was trained on, the configuration settings you choose, we'll talk more about those, and even seemingly small things. Your exact word choice, the writing style, how you structure the prompt, the context you give it.
It's like a lot to juggle.
It really is. It's this complex interplay.
Yeah.
And the paper makes it clear, if your prompts aren't well designed, you risk getting responses that are, well, ambiguous, maybe inaccurate, or just don't hit the mark for what you needed.
Like asking for directions vaguely and ending up lost.
That's a great analogy, yeah. A vague request in a vast library, you'll get lost in irrelevant aisles.
Now, this white paper, it seems to focus specifically on prompting models within platforms like Google's Vertex AI or using their API. Why that focus?
That's a key point, because doing it that way gives you direct access to those crucial configuration settings. Things like temperature, which we'll unpack later. These settings can significantly shape the model's output beyond just the words in your prompt.
Ah, okay. So it's about having more control levers.
Exactly. And the white paper promises to give us the techniques, the tips, the best practices, and also warns about the challenges you might face when you're operating at that level.
Before we get into the techniques themselves, the white paper lays some groundwork on how LLMs actually work. Why is that important for prompt engineering?
It's fundamental, really. It helps to remember that these models, at their core, are prediction engines. They look at the text you give them, the prompt, and then predict the most probable next word or token. Then the next, and the next, based on patterns learned from vast amounts of training data.
So when we write a prompt, we're essentially setting the stage, trying to guide that prediction process towards the answer we want.
You've got it. We're providing the initial conditions, the context, hoping the model predicts a sequence of tokens that forms the kind of response we're aiming for. It's about steering the predictive engine.
And the white paper mentions prompts can do a huge range of tasks.
Oh, absolutely. The versatility is remarkable. Summarization, extracting specific info, Q&A, classification, translation, both language and code, generating new code, documentation, even complex reasoning. It's amazing what well-crafted text can instruct these models to do.
But it also notes that a prompt that works wonders on one model might need tweaking for another.
Yes, that's crucial. But what gets great results on Gemini might need adjustment for GPT or Claude or Llama. They have different training, different architectures. You often need to optimize prompts for the specific model you're targeting.
Okay, that makes sense. Now, you mentioned configuration settings earlier. The white paper dives into those next, right? The LLM output configuration.
It does. These are the knobs and dials, separate from the prompt text itself, that control the characteristics of the output.
Let's break them down. First up is output length, the token limit.
Right. Basically, the maximum number of words or parts of words the model will generate. More tokens means more computation, potentially higher costs, longer waits.
But just lowering the limit doesn't make the answer better, does it? It just cuts it off.
Exactly. It just stops predicting. If you want a succinct answer, you still need a good prompt telling it to be brief. Lowering the limit just prevents it from rambling on past a certain point. The paper notes this is important for some techniques, like React, to avoid runaway generation.
Okay. Then we get into sampling controls. This sounds more complex.
It is, but it's where you get really fine-grained control. See, LLMs don't just pick the single most likely next word. They calculate probabilities for many possible next words. Sampling controls determine how the model chooses from that probability distribution.
Right. And the first control is temperature.
Yeah, think of temperature as controlling randomness.
Hmm.
Low temperature makes the model more deterministic, more focused. It strongly favors the highest probability words, leads to predictable, often factual responses.
And zero temperature is completely deterministic.
Pretty much. It
Yeah.
picks the top probability token almost every time. Though technically, tiny variations might occur if there are exact ties in probability.
And higher temperatures.
That injects more randomness. The model is more likely to pick less probable words. This can lead to more creative, diverse, sometimes surprising outputs, but crank it too high, and things can get nonsensical or incoherent.
So it's a trade-off between predictability and creativity.
Exactly. The paper mentions it relates to the softmax function. Low temp sharpens the probabilities onto top choices. High temp flattens them out, making more tokens viable options. More creative freedom, but less predictability.
Okay. Then there's top K and top P sampling.
Right. These are ways to narrow down the choices before sampling. Top K means the model only considers the top K most likely next tokens. A higher K means more choice, potentially more creativity. Lower K is more restrictive.
And K1 would be like zero temperature again?
Essentially, yes.
Right.
It forces the model to pick the single most likely token.
And top P, or nucleus sampling.
That's slightly different. It selects the smallest set of top tokens whose probabilities add up to at least P, a value between 0 and 1. So if P is low, like 0.1, it might only consider one or two very likely words. If P is high, like 0.95, it considers a wider range until their combined probability hits that threshold.
Which one should you use, K or P, or both?
Good question. The white paper suggests, honestly, experimentation is often key. The best approach depends heavily on your specific task and what kind of output you want. Sometimes one works better, sometimes the other, sometimes a combination.
Okay, so putting it all together, these settings interact.
They definitely do. That's a crucial takeaway from the paper. The best combination of temperature, top K, top P, and output length depends entirely on your goal. And you need to understand how they influence each other.
How do they typically interact? Is there an order?
Usually, if all three sampling controls are available, the model first filters the possible next tokens using both top K and top P rules. Then it applies the temperature setting to sample from that narrowed down list.
And if only one is available?
Then just that one filter is applied before sampling, or if temperature isn't available, it might just pick randomly from the filtered set.
And extreme settings can override others.
Absolutely. Temp at 0 makes K and P mostly irrelevant because it's just picking the top choice anyway. K1 forces the top choice, negating the others. A very low P might only leave one token, again, making the others less impactful.
Does the white paper give any starting points, like rules of thumb?
It does offer some general recommendations. For, say, relatively coherent but still creative stuff, maybe 10.2, top P VN, pop 9.5, top K 30. For highly creative, maybe 10.9, top P 0.9, top K 40.
And less creative, more factual.
Maybe 10.1, top P 0.9, top K 20. And for tasks with one right answer, like math, definitely start with temp 0.
Bet there's a warning too, right? More freedom can lead to less relevant output.
Yes, exactly. Higher temperature, higher KP, longer output limits, they all increase the chance the model might drift off topic or generate things unrelated to your prompt. It's a balancing act.
And they mentioned that repetition loop bug. Ugh, I've seen that.
We all have. The paper explains it can happen at both low and high temperatures, interestingly. Low temp can get stuck on a high probability loop. High temp randomness can, just by chance, circle back to previous states. The key is careful tinkering with these settings to find a stable zone.
Okay, this gives us a much better handle on the controls. Now let's get into the core, the prompting techniques.
Right. The paper stresses that while LLMs want to follow instructions, clear, well-designed prompts are much better. And specific techniques leverage how these models actually learned.
First up is general prompting or zero shot, the simplest form.
Pretty much. Zero shot means zero examples. You just give the task description and maybe some starting text to question, start of a story, whatever. No examples of what the output should look like.
Can you give an example from the paper?
Yeah, they use movie review classification. The prompt is just the review. Her is a disturbing study. I wish there were more movies like this masterpiece. Using Gemini Pro at a low temp, 0.1, the model correctly outputs positive, even with tricky words like disturbing.
So for simple tasks, zero shot can be enough.
Often, yes, if the model's general knowledge covers it. The paper also introduces the idea of documenting prompts here, using a table format, something they emphasize later as a best practice.
Okay, what if zero shot isn't enough?
Then you move to providing examples. That brings us to one-shot and few-shot prompting.
One shot is just one example.
Exactly. You include a single input-output pair in your prompt to show the model the format or pattern you want, like a single template.
And few shot is multiple examples.
Right. Usually 3 to 5, maybe more or less, depending on the task complexity, how good your examples are, the model's capability, and importantly, the input token limit. You can't make the prompt too long. The goal is to show the pattern more clearly.
They had an example for few shot, too.
Right.
Yeah?
Yes, parsing pizza orders into JSON. They show a couple of order JSON examples, then give a new complex order. Large pizza, first half cheese and mozzarella, other half tomato sauce, ham and pineapple. Because of the examples, the model correctly parses it into the target JSON structure.
And the quality of those examples matters a lot.
Hugely. They need to be relevant, diverse, well-written, accurate. Even small errors can confuse the model. And including edge cases in your examples helps the model become more robust.
Okay, next up. System, contextual, and role prompting. How do these differ?
They all guide generation, but focus differently. System prompting sets the overall stage, the big picture, like you're a French translator or classify the following text. It defines the fundamental role or capability for the whole interaction.
Got it. And contextual prompting.
That's more dynamic, task-specific. You provide background details relevant right now. Given this customer's purchase history, insert history, suggest related products. It adds immediate nuance.
Okay, so system is the overall job, context is the immediate situation. What about role prompting?
Role prompting assigns a specific persona. Act as a cynical movie critic, or you're a helpful librarian. This shapes the tone, style, knowledge base, and behavior consistently. It gives the output personality.
There seems to be some overlap.
There can be, yeah. But the primary focus differs. System capability, context, immediate details, role, persona style.
Any examples of these in action?
Definitely. For system prompts, they show classifying movie reviews but instructing it to only return the uppercase label, positive, negative, or outputting the classification as structured JSON according to a specific schema. They also mention system prompts for safety rules like be respectful.
And role prompting.
They show asking the model to act as a travel guide for Amsterdam museums. It gives relevant suggestions. Then they change the role to a humorous travel guide for Manhattan, and the tone and suggestions change completely. Defining the role provides that blueprint. They even list styles like confrontational, formal, inspirational.
Lots of options there. And contextual.
The example involves providing context about a blog focusing on retro 80s arcade games, then asking for article ideas. The suggestions are spot on for that niche because of the provided context.
Okay, this next one sounds intriguing. Step back prompting. What's the idea here?
It's clever. Instead of asking your specific question directly, you first ask a more general, related question, get the answer to that, and then use that answer as context when you ask your original specific question.
Why do that?
The idea is it helps the LLM activate relevant background knowledge and general principles before tackling the specific problem. It sort of primes the pump with broader concepts, which can lead to more accurate, insightful answers for the specific task. It might even help mitigate biases by starting from a more general perspective.
Can you walk through the example they used?
Sure. They wanted a storyline for an FPS game level. A direct prompt might be okay, but generic. With Step Back, they first asked, list 5 fictional key settings in popular FPS games. It listed things like abandoned military base, cyberpunk city, underwater research facility.
Okay.
Then they took one of those underwater research facility and used it in the final prompt. Generate a storyline for an FPS level set in an underwater research facility. The resulting storyline was much more specific and engaging because it was grounded in that pre-established concept.
Oh, that's smart. Okay, moving on to chain of thought, CQ. This is about reasoning.
Exactly. Yeah. County prompts the LLM to generate intermediate reasoning steps to basically show its work before giving the final answer. It's really effective for complex tasks needing logic or calculation, especially when you combine it with few-shot examples showing that step-by-step process.
What are the pros and cons?
Pros. It's pretty easy to implement, works well off the shelf, gives you interpretability, you see how it got the answer, and seems to make prompts more robust across model versions. Con. More output tokens, so higher cost and latency.
How does it work in practice?
They show a simple math problem. When I was 3, my partner was 3 times my age, 9. Now I'm 20. How old is my partner? A direct prompt often gets it wrong.
Right, they'd be 26 now.
Exactly. But by just adding, let's think step by step, that's zero-shot COT, the model correctly lays out the logic. Partner was 6 years older, 936. So now partner is 20 plus 6, 26.
Wow, just adding that phrase helped.
It often does. They also show one-shot QT, giving one example of a similar problem solved step by step, which makes the model follow the same pattern for the target question.
Where else is QT useful?
Code generation. Breaking down requests, creating synthetic data, guiding assumptions, basically anything you'd solve by talking yourself through it.
Okay. Building on COTI's self-consistency. What's that?
It takes COTI a step further for reliability. Instead of relying on one reasoning path, you run the same COTI prompt multiple times, maybe with a higher temperature, to get diverse reasoning paths.
Okay, so you get several different step-by-step answers.
Potentially, yes. Then you look at the final answer from each path and choose the one that appears most often, majority rules. It's like getting multiple opinions and going with the consensus. More robust, but higher cost again.
Can you give the example?
Email classification. Important or not important for an ambiguous email. Running a COTI prompt several times might yield different reasoning and different final classifications. Self-consistency looks at all those classifications and picks the most frequent one as the most reliable answer.
Makes sense. Then briefly, tree of thoughts. 2T.
Yeah, the paper just touches on it. Think of it as generalizing COTI. Instead of one linear chain, the LLM explores multiple reasoning paths concurrently, like branches of a tree. Good for really complex problems needing exploration.
And react. Reason and act.
This one's cool. It combines reasoning with action. The LLM can use external tools like a search engine or a code interpreter. It follows a loop. Reason about the problem, plan an action, in simple search web, perform action, observe results, update reasoning, plan next action.
Like how humans solve problems using tools.
Exactly. The example uses LangChain and Vertex AI to find the number of kids Metallica members have. The React agent searches for each member's kids, gets the numbers, and then adds them up.
Powerful, but sounds complex to set up.
It requires managing that interaction loop and providing good instructions. Yeah.
So, okay, automatic prompt engineering, APE. Using AI to write prompts for AI.
That's the gist. You use one model to generate variations of a prompt for a task. For instance, generate 10 ways to ask for one Metallica t-shirt size S.
Then what?
You evaluate those generated prompts automatically, maybe using metrics like BLEU or Rouget, to see how well the outputs from those prompts match a desired standard. Then you pick the best performing prompt. You can even iterate.
Automating the optimization. Clever. Finally, code prompting.
Right. Even though Gemini focuses on text, that includes prompts about code.
Like writing code.
Yep. Example, asking for a bash script to rename files by adding draft. The model generates the script, often with comments, but the paper stresses. Always review and test generated code.
Good advice. What else?
Explaining code. Give it code. Ask what it does. It provides detailed explanations. Translating code. Ask it to convert, say, the bash script to Python. Debugging. Give it broken code and the error message. Ask it to fix it.
And it finds the bugs.
In the example, yes.
Yeah.
It found a 2 uppercase error in Python, suggested upper, and even offered other improvements like error handling and better string formatting. It's like an AI pair programmer.
Wow. Okay, quick clarification. Multimodal prompting.
Just a brief note in the paper distinguishing it. That's using multiple types of input text, images, audio code together in a prompt. Different from just using text to talk about code.
Got it. Okay, that covers the techniques. Let's move to the best practices. How do we put all this into action effectively?
The absolute first point they make is experimentation is key. Use a platform like Vertex AI Language Studio to try things out, see what works.
And what's a major best practice they highlight?
Provide examples. Back to one-shot, few-shot. It's just so effective for teaching the model the output format, style, tone you want. Big impact on accuracy.
Makes sense. What else?
Design with simplicity. Keep prompts clear, concise, easy to understand. Avoid jargon or unnecessary fluff. They show a before-after travel prompt rewrite that's much cleaner. Use strong action verbs.
Be direct.
Yeah. And be specific about the output. Vague instructions lead to vague results. Use system or contextual prompts to provide details. Clear do versus do not examples again for a blog post prompt.
Okay. This one's interesting. Use instructions over constraints. What's the difference?
Instructions tell the model what to do. Write in a formal tone. Constraints tell it what not to do. Don't use slang. The papers suggest positive instructions are often more effective.
Why?
Instructions clearly state the goal. Constraints can sometimes limit creativity or clash unexpectedly. Constraints are still useful, especially for safety or rigid formats, but the advice is prioritize instructions, use constraints carefully, and test.
Right. Then control the max token length. We discussed that with configuration.
Yep, either in the settings or by asking for a specific length in the prompt, like summarize in tweet length.
Use variables in prompts. That sounds useful for applications.
Definitely. Makes prompts reusable. Instead of writing suggest travel tips for Paris, write suggest travel tips for city and insert the city name dynamically. Very practical.
And experiment with input formats and writing styles. Try questions, statements, instructions.
Exactly. See how phrasing impacts the result. The Sega Dreamcast example shows this.
For a few-shot classification, they had a specific tip.
Yeah. Mix up the classes in your examples. Don't put all the positive examples first, then all the negative. Mix them randomly. Prevents the model overfitting to the order. They suggest maybe 6 examples to start.
Good tip. And adapt to model updates. Keep learning as the tech changes.
Crucial. Models evolve. Prompts might need adjusting. Use tools like Vertex AI Studio to manage and test prompt versions.
What about output formats?
Experiment with output formats. Especially for non-creative tasks like extraction or parsing, use structured formats. JSON is highly recommended.
Why JSON?
Consistent style focuses output on needed data, fewer hallucinations, shows relationships, defines data types, sortable. Lots of benefits.
But JSON can break if cut off.
It can, which leads to JSON repair. The paper mentions libraries like JSON repair that can automatically try to fix malformed JSON caused by truncation. Very handy.
And going further, working with schemas.
Yes, using JSON schema to define the expected structure of JSON data, even for input. It gives the LLM a blueprint, helps it focus, understand relationships, data types, really valuable for complex data or apps.
Collaboration helps too. Experiment together.
Yeah, work with other prompt engineers, see different approaches, learn from each other, find more robust solutions.
Any specific best practices for CowT?
Yes. Put the answer after the reasoning steps.
Yeah.
You'll need a way to extract just the final answer later. And set temperature to 0 for CoT, usually, since you want logical deduction, not randomness.
And the final, maybe most important practice.
Document everything. Keep detailed logs. Prompt text, model settings, output, whether it worked, okay, not okay sometimes. Feedback. Use a spreadsheet, like the template they provide.
Why is documentation so vital?
For learning, revisiting, testing across model versions, debugging. If prompts are in code, use version control, automated tests. Prompt engineering is iterative. Craft, test, analyze, refine, retest, especially when models update.
Wow, okay. That's a comprehensive overview of the white paper. So bringing it all together, what are the main takeaways?
Well, I think the main thing is that prompt engineering really is a crucial skill now. It's not just typing. It's understanding how these LLMs work and systematically experimenting with techniques and settings to guide them effectively.
Right. It's about moving beyond basic questions to actually engineering the interaction to get better, more accurate, more relevant results.
Exactly. Applying these principles, these best practices we talked about, that's how you unlock more of the potential these models hold.
It really changes how you think about talking to AI.
It does. And, as we wrap up, here's something to think about. Mastering this kind of prompt engineering, it doesn't just help with today's AI. How might it prepare us for the whole evolving landscape of human-computer interaction? What new ways of communicating, of discovering knowledge might open up as we get, more fluent in speaking the language of AI?